So this is a problem from the 2003 AP exam free response set. It was actually on Form B of the exam, and it's a non-calculator question. It's problem number 4, and the way that this question starts is they provide us with a situation where a particle moves back and forth on the x-axis with velocity at time t defined to be greater than or equal to 0 given by this. So we have a velocity function to work with here. And what they ask us to do in part A is they ask us to find the acceleration of the particle at time t is equal to 3. So what we need to know to figure out part A is we need to realize that acceleration would be the derivative of velocity. So if we wanted to find an acceleration function, we would just say that our acceleration function, a of t, is going to be equivalent to v prime of t. And to find v prime of t, the derivative of this -1 is 0, and then the derivative of e to the 1 minus t is going to require a little chain rule. So we'll do the derivative of the outer function, but we're not going to leave an x or a t in the exponent. We're going to leave the inner function there. And then we're going to multiply by the derivative of the exponent. And the derivative of 1 minus t is -1. So we want to know what the acceleration is at 3. So the acceleration evaluated at t equals 3 is going to be e to the 1 minus 3 times -1. Well, the base e times -1 is basically just going to make the coefficient of e negative, and then e to the 1 minus 2, well, that'll be e to the -2nd. And without a calculator, there's not really much else you can do with this other than if you wanted to simplify it and write it without the negative exponent, you could write it as -1 over e to the +2nd. So either of these would be fine for the acceleration of the particle at time t equals 3. In part B here, they want us to figure out if the speed of the particle is increasing at t equals 3, and then give a little bit of a reason for your answer. So in calculus, the easiest way to think about speed is to define speed to be equivalent to the absolute value of velocity. So I'm not going to sketch this velocity graph. I don't really know what that looks like off the top of my head. But if we had a velocity graph, so velocity was plotted over time, if velocity is moving upward, away from 0, its absolute value would be getting larger, so speed would be increasing. So here's an interval where speed is increasing because my velocity is moving away from 0. My speed is decreasing on this interval because now my speed is moving closer to 0. When I'm at this point and I cross this point and work back down below the t-axis here, my velocity is now moving away from 0. So the absolute value of velocity, or speed, is actually increasing right here. And then if I bottom out and come back up, now my speed is decreasing again because my velocity is getting closer to 0. The absolute value of velocity is getting smaller. So you need to know what is happening with the velocity graph at the point you're asked a question about speed at. So we need to know what's happening with our velocity graph at t equals 3. Well, we already know this. In part A, we figured out that a of 3 was going to be equal to, what, -1 over e to the 2nd. What is the velocity at 3? Well, if we figured out the velocity at 3, that would be equal to, what, -1 plus e to the 1 minus 3. And if we simplify that a little bit, we're looking at -1 plus e to the -2nd. So let's think about this here. We have a negative acceleration at 3. What's the sign of this? So basically what I'm trying to do is I'm trying to get to the point where our velocity graph, we're going to be able to draw a little portion of it near the t value of 3. So if this is where t is 3, based on this right here, the fact that acceleration is negative, we have a negative value divided by a positive value, we know that the slope of the tangent line to this graph, acceleration is the derivative of velocity, and hence the slope of the tangent line on this graph, we know the slope of the tangent line has to be negative. So what this implies about what we're trying to graph here is that the slope of the tangent line at 3 on this velocity graph has to be negative, has to be less than 0. So let's see, do we need to draw a graph above the t-axis or below the t-axis that has this negative slope. Because if we have a negative slope and we're above the x-axis, we're going to be coming closer to 0 in a decreasing speed. But if we have a negative slope like we do right here and we're below the t-axis, we're going to have an increasing speed because the absolute value of velocity, the distance this is from 0, is getting larger. So let's see, 1 minus e to the negative second. This v of 3 value, is it positive or is it negative? Well, e to the negative second is really 1 over e squared. And e squared, if you're trying to estimate that, e is about 2.7. E to the first is about 2.7. So if you just round that off to 3, what's 1 over 3 squared? Well, 1/9. Negative 1 plus 1/9 is clearly a negative value. 1 over 2.7 squared is also going to be a negative value. So our velocity is negative, meaning that at the t-value of 3, we have a velocity that's negative, so our velocity graph is going to be below the x-axis or the t-axis, and we have a negatively sloped tangent line. That's indicated by the fact that the derivative of what we're trying to graph here is negative. So although we don't really know exactly what the graph looks like, we do know that we have a negative velocity and a negative slope on the velocity graph at 3. And on this little piece of the graph, isn't velocity getting further from 0, further from the t-axis? So because of that, our speed is increasing. So is the speed of the particle increasing? Yes. And I'm not going to take the time to write out the reason, but the reason why is because the velocity graph is moving further from 0 at that t-value. And it has to do with both velocity arguments and acceleration arguments combined to answer the question about speed. In part C, find all values of t at which the particle changes direction, justify your answer. So the particle is going to change directions anytime velocity changes from positive to negative or negative to positive. So what we're going to have to do here is we're going to have to basically use this little sign chart that we've been using a little bit in class, and we're going to want to figure out what the sign of velocity is. What's the sign of velocity, the sign of v of t on several different intervals here? So the only time that the sign of velocity can change is if velocity is first undefined or first 0. So if we set velocity equal to 0 and we try to solve this, the fact that this is a non-calculator question makes this, I guess, a little bit tricky. But if you're trying to solve an equation involving an exponential without a calculator, isolate the exponential, so add 1 to each side, and then the exponential is by itself, and then get rid of the exponential. So to get rid of the exponential, we're going to do the natural log of each side. So we do the natural log of 1, and then the natural log of this side is just going to leave us with 1 minus t. Now if you think about the natural log of 1, the graph of the natural log of x looks like this. So this point on the graph is the point 1 comma 0. So the natural log of 1 is the one value of the natural log function that you should know. It's 0. So if you're solving this for t, add the t over to the 0, and you get t equals 1. So the only time the velocity function is equal to 0 is when t is equal to 1. The velocity function's never undefined. E to a power is always defined. So the only time that the velocity could potentially change signs is as we cross the t value of 1. And if we check the sign of velocity over here and then over here, I think what we said in part B was that at 3, right, if I click back to part B, at 3 we have a velocity that's negative, a velocity that's beneath 0. So what we can say here is that if we pick the test value of 3, we're going to get a negative velocity, meaning that the velocity must be negative at any value of t from this portion of this number line. And then on the other side, if you pick a value like 1/2, try to figure out what the velocity is at the t value of 1/2. So that's going to be equivalent to negative 1 plus e to the 1 minus 1/2. So that's equal to negative 1 plus, that's e to the 1/2. So that's the square root of 2.7. Well, the square root of 1 is 0. Or excuse me, the square root of 1 is 1. Negative 1 plus 1 is 0. But then the square root of 2.7 is going to be a value that's bigger than 1. So -1 plus a value bigger than 1 is going to give us a positive value back in the end. That value is bigger than 0. Our velocity is positive there. So the object changes directions once at the time when velocity changes signs, and it happens at the t value of 1.